I hope you all are doing wonderful. So as you all know that I have started with the JEE Mains previous year solve problem solving session, and in this problem solving session I'm going to be continuing with the portion of algebra. And today's take will be on the topic of quadratic equation. So if you are someone who is new to this particular platform and haven't started watching me from the beginning, then this is basically a take where I basically start on each and every topics of mathematics, and I basically start solving the top 10 and top 15 important previous year questions. Those particular questions are the most probable questions for your paper. Alright, so with this I will be starting with today's discussion on quadratic equation. So if you are new to this particular platform, then I would request you to go to the description box of this particular video and start watching the playlist. Alright, so with this my take will be on quadratic equation, and I have already covered the coordinate geometry part. Let's start with today's goal, and today's goal will be on the quadratic equation. So today's goal will be basically to solve the top 12 important JEE Mains questions. Okay, so I took up the top important questions. Alright, so many students were asking me to take up the difficult and the other also different questions from the old paper as well, like 2021, 2020, 2019. So my basically my advice to all of you will be basically to solve it upon yourself. What is basically my advice is basically develop a problem solving approach, okay, based on which you can solve different numerical types of questions, okay, various types of problems that are basically asked in the examination. All right, so you must not totally rely on me. What my task is to basically to give you a pathway, all right, to basically how the problems are actually approached and what are the important problems that basically are exam oriented. Okay, exam oriented problems are which one. Okay, so I hope you will respect my decision and start to solve on yourself, because after all you have to solve examining questions in the examination form of temperament. All right, so with this my very first question is on the screen. So if you know me, then basically pause the video at this particular moment and start to solve this question on your own. Afterwards tally your answer and definitely comment me in the comment section how much you are getting as a score out of 12. Like for example, if there are 12 questions and all questions are +4 and for negative it is -1, so definitely rate it in the comment section. I will be very happy for your comments. So with this, let us start to solve the first question. And the first question on the screen, it says the number of real roots. So it is asking me for the real roots for the equation. So it is giving me an equation, okay, which is basically equal to 0. So let us write the equation. So the equation is x into mod of x minus. So the very first equation we have x into mod of x into minus 5 into 2 plus x mod plus 6 is equal to 0. So we basically have a modulus function, okay, in this question. So there will be various cases. So because of those cases, we will have different possibilities of opening this particular the absolute functions. All right. So let us first take the cases. So what are the basically critical point for this mod function? So we know that when mod of x plus alpha is equal to 0, we basically look for it is equal to 0. This particular function has a graph. Okay, so for example, x plus alpha is equal to 0. So then x minus of alpha. So if you consider this is minus alpha, and the graph will be something like this. Okay, so there will be straight lines. Okay, so this is the graph of the modulus function. Okay, if this is y-axis and if you consider this as the x-axis. All right, so this will be a graph of the modulus function. Now since modulus function is always positive, that means this particular value is only 0 at only one point. So there will be various cases regarding it, but what my intuition or idea is basically to obtain the critical points. So from this particular equation, if you see, the critical points occurs at x is equal to 0 and x is equal to -2. Okay, so those are basically critical points. So let me first write the critical points as, that means that about the critical point, the opening of the bracket will have two different signs. Okay, like for example, if x is greater than -2, then it will open in positive, and similarly if x is less than -2, then it will open up in negative sign. That means the critical points are, so if you have covered the chapters, you must have understand what I am speaking of. So the critical points are 0 and 2. All right, so let us now make some cases and let us solve this particular problem. So the very first case is basically a case when x is less than -2. So if x is less than -2, then of course the mod of x will obviously open in the negative sign, and this will make it minus of x squared. Okay, and since x is less than -2, that x plus 2 will open with a negative sign, and that will give me plus of 5 times of x plus 2 plus 6 is equal to 0. So if I take minus common from this particular equation, the equation I will obtain is as x square minus 5x. Okay, and and if I will get over here minus 10 and minus 6 is basically minus 16 is equal to 0. Excuse me. And from here I will get the value of x as, so if I use the quadratic formula, I will get the value of x as, so 5 plus minus root under 25 minus of minus, that is plus 4 times of 16, okay, and whole divided by 2. So with this I will get the roots as 5 plus minus root under, this will be 89, okay, 25 plus 64 is 89 divided by 2. All right, so if I look at this particular value, so what I need to get the value of x, which is basically less than minus 2, okay, which is less than minus 2. But if you look at the situation, x is equal to 5 minus root under 89 divided by 2. All right, so if you look at this particular value is also rejected, okay, because if you can definitely sense out, if you take the plus sign, it is obviously rejected. So if you take this 5 plus root under 89, it is rejected because x is not less than minus 2. And similarly for this particular case, now you have to look for the nearest square of 89. So if you look at 89, the nearest square of 89, or if you consider, okay, it's 100, okay, the nearest square is 100. So if we consider 100, so this value will basically be equal to 5 minus, so if you consider the minus sign, okay, so the 5 minus root under 89 divided by 2, and the closest value is basically 100. So that means the root under 100 is 10, that is 5 minus 10 by 2, that is minus 5 by 2, and that comes out to minus 2.5. But the x should be less than minus 2. So so if you can put this, but if you actually calculate the value of 89, okay, which you can basically, and also it is less than, so the next square is basically 81, okay, that is 9. So if you consider this 81, okay, because what I can say like this, okay, 89 lies in the range of 81 to 100. But if you compare with 100, this approximation on the error I will get more. But if you compare with 81, the approximation of the error I will get it as less. So if I consider 81, then square root of 81 is 9, and 5 minus 9 is basically minus of 4. Minus 4 by 2 is minus 2. But the x value should be less than minus 2. So if I considered acceptable value, then it is definitely acceptable. That means this particular value is acceptable. This particular value is acceptable. Okay. Alright, so from this particular case, I only get one solution, and that is x is equal to 5 minus root under 89 whole divided by 2. And for the second case, now let us consider the case 2. Now these types of problems are always to be solved in cases, okay. And the case 2 will be the case when x is less than 0 but greater than or equal to minus of 2. Alright, so if this particular case arises, then again this will be minus of x square. But in this second case, that is x plus 2 mod of x plus 2, it will open in the same, the positive way. So this is minus of x plus 2 plus of 6 is equal to 0. Again, if I take the x minus sign as common, this will be x square plus 5x, okay, x square plus 5x, and this will become equal to plus of 4 is equal to 0. So from here I will get the roots as minus 4 and minus 1. But since minus 4 is not lying in this range of the values of x, that is 0 to minus 2, therefore this particular value is neglected, and the only solution I get it as x is equal to minus 1 is the only solution, okay, is accepted solution. So I am writing it as accepted solution. Okay, now the last case will be the case number third, and the last case will be basically when x is greater than or equal to 0, greater than or equal to 0. So for this particular case, the modulus of x will open in positive sign, so this will make you x square minus 5 times of x plus 2 plus of 6 is equal to 0. So this will give you the quadratic equation, which is x square minus 5x minus 4 is equal to 0. So from here you will get the root as 4 comma 1, sorry, very sorry, not 4 comma 1. So from here you will get the roots as, okay, so you have to basically apply the quadratic formula, and that is 5 plus minus root under 25 minus 4 times of minus of 4, that is minus 16, okay, minus and minus is will plus 16 divided by 2, and the result will be 5 plus minus root under, so this result will come out as, so if you add it, it will be root under 41 divided by 2. Now if you consider the negative sign, now root under 45 is basically close to, so you have to basically look for the closest one. So basically lies between 49 and 36. So if you consider the minimum value 36 and then root under 36, so 5 minus root 36 is 5 minus 6 by 2, that will be basically negative. So from here the only accepted value, So the value which is basically accepted. All right. So from here you can definitely see that you can look for also. Also let me check for whether what else conditions are given. So from here, if you take this particular value, that 5 minus root under, so you get 5 minus root under 41 by whole divided by 2. So if you consider this it to be less than 49, and there will be 5 minus 7 by 2. Okay, so 5 minus 7 will be minus 1, because in this case the result will be basically, obviously this result is always negative. So this will not be the accepted solution. The solution which is accepted is basically 5 plus root under 41 by 2. So this is the accepted solution. Now this is accepted. Okay, so this is accepted solution. All right. So with this, I basically get three real roots. Okay, so with this particular equation has three real roots. Okay, so the number of real roots will be equal to 3, and with this the right answer to this particular problem will be option number B. I hope you have understood this particular problem. Pretty decent and simple problem, but again you might make mistakes in the sign conversion. Alright, so that's the important thing that I wanted to portray to this particular problem. I hope you will remember this particular problem. Alright, now with this let us move to the next problem, and this is the most important type of problem that gets repeated many number of times in your examinations. Alright, so the question, if you look at it is saying that alpha and beta are the roots. Roots means basically the solutions of this particular equation, x square minus root 2 times of x plus 2 is equal to 0. So it is saying that it has two roots. One root is alpha and the second root is beta. So it is asking you for the value of alpha raised to the power 14 and beta raised to the power 14. All right, so I will be teaching you a very important, okay, a new method of solving this particular problem. Since, and if you apply the quadratic formula for taking out the roots, you will basically find the roots as root 2 plus minus root under. Now root 2 whole square is 2 minus 4 times of 2 whole divided by 2. So with this you will get the roots as root 2. So we will get the roots as root 2 plus minus root 6 iota whole divided by 2, where iota is basically root under minus 1. So iota is basically root under minus 1. Okay. Now we basically have the roots as, so from here I got the roots as root 2 plus root 6 iota by 2, and other root as root 2 minus root 6 iota by 2. So I basically get two complex numbers as the roots. Okay. Now what I want to do in this particular problem, but since I have to basically get for the value, so these are basically alpha and beta values. Okay, so these are basically alpha and beta values. Now I have to get for alpha to the power 14 and beta to the power 14. Now here comes the catch. You basically need to understand. So the very first thing you can observe from these two complex number, both of the complex number are basically at same modulus. Okay, so if you try to find the modulus of this complex number, so I write this complex number as z. So if I try to find the modulus of this complex number, I'll get it as root under, so root 2 by 2, that is basically 1 by root 2, 1 by root 2 whole square. Okay, 1 by root 2 whole square plus, and this will be root 6 by 2 whole square. Okay, so this will be root 6 by 2 whole square, and this will evaluate out as 2 by 4 plus this will be 6 by 4. So if you evaluate this will come out as root 2. So the modulus or the magnitude of this complex number of both this complex number is basically same, and it is basically equal to root 2. Alright, so therefore what I'm trying to do, so because I get the roots as a complex numbers. Okay, because I get the roots as complex numbers, so what I'm using, the notation of the complex number I will be using is basically z is equal to e r into e raised to the power I theta. That is the Euler notation. So I hope you have studied this in your complex numbers. Okay, so this is the Euler notation. Okay, so this is the Euler notation of writing the complex numbers. Euler notation. Okay, so I will be using the Euler notation, or you can call it as the Euler notation of writing the complex numbers. All right, so if I write in this particular format, and then I can definitely express alpha and beta of this particular nature. So from here, if I represent the alpha, so alpha is the very first value which has a positive one in it. So if I definitely approach alpha as, I can write this modulus of alpha is basically root 2 e raised to the power I theta. Now theta, this theta value will basically come from tan inverse of the y by x, that is basically imaginary part of this, which is basically imaginary part of this complex number divided by the real part of this complex number. Imaginary part of this complex number divided by the real part of this complex number, and if you compute this, you will get the value of theta. So for the very first value that I have as root 2 plus root 6 iota by 2. So if I calculate theta from here, I'll get theta as tan inverse of, so root 6 by 2 divided by root 2 by 2. So this will basically give you, okay, so this is basically give you the value as, so this is tan inverse of root 3. Okay, so this will give you tan inverse of root 3, and that is basically pi by 3. Okay, 60 degree. And similarly for other root, that is root 2 minus root 6 iota by 2. If you compute this, the theta value, so let me write this as theta 1 and theta 2. So this will again give me the value tan inverse of, so this will give you the tan inverse of value as minus root 6 by root 2, and that is basically minus of pi by 3. Okay, so from here I can write alpha as equal to root 2 e raised to the power I pi by 3, and similarly beta I can write it as root 2, okay, beta I can write it as root 2 e raised to the power minus iota pi by 3. So I got to the values of alpha and beta from here. Now what I will apply the principle of, now alpha raised to the power 14 and beta raised to the power 14 is basically the value I need to calculate. So let me write that as sum s. So the sum s is equal to, now alpha raised to the power 14, there is root 2 into e raised to the power iota pi by 3 whole raised to the power 14 plus root 2 iota raised to the power minus I pi by 3 whole raised to the power 14. Alright, so now if you calculate, this will be basically 2 raised to the power 7. So you can take 2 raised to the power 7 common, and the value will come out as, okay, now this values basically, the value will basically equal to e raised to the power minus 14 pi by 3 iota, okay, sorry, plus, and plus of e raised to the power minus 14 pi by 3 iota. So that's the basically the sum you will obtain. Now people again get confused, is that basically how to convert this. Okay, now you can know the trigonometric conversion, because what we can write when we basically write the z as r e raised to the power I by theta, I can also write this particular value as r into cos theta plus I sin theta, and that is the polar notation of writing the any complex number. So that is a polar notation. Okay, and in polar notation, this theta basically belongs to this argument. Now this argument which I basically obtained over here is 14 pi by 3. Now since this particular argument basically are in form of sin theta and cos theta, so they are basically periodic. That means 14 pi by 3 can also be written as, so you can do this 14 pi by 3 as 14 pi by 3 as, so you can write this as, so you can write this as 4 pi plus 2 pi by 3. And you know that whenever we apply for any trigonometric value, we add a 2 pi or a 4 pi or any even multiple of pi to this particular argument. That means I want to say the angle, we basically obtain the same result. Only the thing is basically you need to look for is the sign. But again, if you look at the sign, you whenever you perform even number of multiple of pi, sorry, even multiple of 2 pi, even multiple of 2 pi, you basically end up landing in the first quadrant. If you started with the first quadrant, you'll end up landing in the first quadrant itself. All right, so that's basically the idea, is to perform. And from here you can definitely write this. So that means this will be 2 to the power 7, and the value will be coming out as, so 2 to the power 7 is 128, and so you can definitely do this as 128 into, so this value will be 128 into, and now this particular value can also be written as e to the power 2 pi by 3 iota plus e to the power minus 2 pi by 3 iota. And if we can write that e to the power minus iota 2 pi by 3 plus e to the power minus 2 pi by 3 iota, and I can definitely use this, now I can make use of the polar form or the polar notation of the complex number representation, then I will get it as 2 times of cos of cos of 2 pi by 3. Okay, so if I use a polar notation, I will get it as 2 to the power 7 into 2 times of cos of that particular argument angle. And if you solve and if you calculate this value, so this value will be coming out as, and now cos of 2 pi by 3 is basically equal to minus 1 by 2. So from here the answer will be equal to minus 228, because 2 and 2 get cancelled. I mean to say the denominator 2 and the numerator 2 get cancelled, and the result you will get is minus 128. I hope you have got this particular answer. And with this answer to this particular problem will be option number D. So that's the right answer to this particular problem. All right, so this was a tricky problem. Okay, now you must have be wondering that how to solve this particular problem from here. you must have seen that this particular problem is very easy, but from here the main idea or the part of solving this problem comes with the help of the notations or the way of representing the complex numbers. So I hope once you have started preparing the complex algebra portion, there will be integrated question as well. All right. So this was the important problem, and this problem actually get repeated many times in the examination situations. Okay. So if you look at the previous year papers, you will find this type of problem was asked in 2022, 21, 20 in all three or in various shifts. Okay. So that's basically my idea, is to make up and basically take up this question just to show us that if in any case this type of problems come out, you are basically able to handle or tackle that particular problem. I wish you can do so. All right. So with this, let us move to the third problem. And the third problem is on the screen. And the very third problem is basically again a very important problem. Okay. So if you look at this is very similar problem to what the problem we basically solved for, is basically the problem on modulus values. So it is saying that A belongs to the set of real numbers. Now the set of real numbers A of all A for which this equation has exactly one roots. Now you have to basically convert this particular into a quadratic equation and get to the condition of exactly one real root. So you know that a quadratic equation, so if I write a quadratic equation as ax plus bx, ax square plus bx plus c is equal to 0. Now if it has, now there are three conditions for this particular quadratic equation. With obviously a, b and c are the real numbers. So for d or discriminant greater than or equal to 0, we basically have, so let me be very specific. Instead of writing d greater than or equal to 0, let me write d greater than 0. So for the values d greater than 0, we basically have real roots. Okay, real unique roots. And if d is equal to 0, then we basically get roots as real roots, but those roots are basically repeating roots. Okay, so this is the case of repeating roots. Okay, and the last case we basically have d less than 0. Then in this particular case we have complex roots. Okay, we have complex roots. Okay, instead of writing imaginary roots, I will basically write it as complex roots. It is better to write it as complex roots. Alright, so that's the important things you must have been knowing from the chapter of quadratic equations. Now, what is the basically the equation? So let me again form cases and let us solve the equation. So the very first case, I will basically write it as, so the critical points from the equation, that is x into mod of x minus 1. Okay, so x into mod of x minus 1 plus x plus 2 mod plus a is equal to 0. So I basically have critical points as, so the critical point as talked in the question number 1, I got the critical point as x is equal to 1 and minus of 2. So from here, if I first take the condition that is x less than minus 2, then I will be getting the equation as x into, both of them will open in the negative sign. So I will get it as x into, so let me write the minus in before, that is minus of x minus 1 minus of x plus 2. Okay, plus a is equal to 0. Now from here, if I look at this value, I will get it as minus of x square plus x minus x, okay, plus a minus 2 is equal to 0. So from here, I'll get the quadratic is as, that is x square plus 2 is equal to a. Okay, so I got the value as x square plus 2 is equal to a. Now if you look at x square plus 2, it is always a increasing function and obviously a positive. So from here, if this particular is having exactly one real root, okay, if this following has only exactly one real root, that means the value. So you can look for that y is equal to, so if you can consider this as y is equal to x square plus 2 is decreasing for all x belonging to minus infinity comma minus 2. So if you can consider the interval of minus infinity and minus 2, you will find it as decreasing function. Alright, so is basically decreasing values. So I have to basically find for the cases or that it has exactly one real root. So if you can look at this particular problem, now x square plus 2 will always be a positive quantity. So x square plus 2 will be somewhere like a parabola with an upward facing like this. Okay. Now if a is equal to now a is equal to x square plus 2 has exactly one real root, that means the value of a must be somewhere like here, okay, must be somewhere here, or maybe less than this, because there are other cases as well, okay, but I have to look for exactly one real root for this particular situation, okay. So you can see this value will be this particular value, the putting y is equal to 0 is sorry, so x is equal to 0 is basically y is equal to 2, so it will start off from 2. All right, so you can observe from here that a value will definitely be equal to, if a equal to 2, then only it can have exactly one real root. Okay, now let us look for the other cases as well, then now we are basically able to understand this problem in better. So if we consider the second case, that is the case 2, where x is less than 1 but greater than or equal to minus of 2. So for this particular case, the solution of the quadratic equation, I will get it as minus of x square plus x plus x plus 2 plus a is equal to 0. So from here the quadratic I will get it as x square minus 2x minus 2 is equal to a, okay, is again equal to a. Now for this particular function, if I can, I can definitely express this particular function as x square minus 2x plus of 1 and minus of 3. That means this will be x minus 1 whole square minus of 3. So I can say that this particular value will be obviously greater than or equal to minus 3. That means for having exactly one root, a must have a value which is like between the range of minus infinity to minus 3, okay. So again, and if you look for one particular solution, we can also write this particular is decreasing, okay, is decreasing in the interval x belonging to minus 2 comma 1, okay, x belonging to minus 2 comma 1, okay. That means for all x belonging to this particular interval, if you look at the values, okay, you will find the values are basically decreasing. That means what I'm basically talking of. So again, and in this previous case, again for this particular interval, the values of x were actually decreasing. All right, very sorry, it's not actually decreasing. If you look at this will be actually increasing, because if you put the values of x from minus infinity to minus 2, the value will go on increasing, okay. but I am talking about decreasing because in the sense when you are approaching from minus infinity to 2, the values are actually getting decreased. Yes, you can see from here the values, if you are approaching from minus infinity to minus 2, okay, x is equal to minus 2, yeah, basically the value is decreasing. You can see the value is decreasing. Again, for this particular range of interval, the values are decreasing for this particular interval. That means this particular function x square minus 2x minus 2 is decreasing in this particular interval. And again we have the third case, and the third case is possible is when x is greater than or equal to 1. So for this particular case, we have the quadratic as x square minus fx plus of x plus 2 plus a is equal to 0. And again I will get the quadratic as, and in this case I will get the quadratic as like x square plus 2 plus a is equal to 0. So if I can write a as minus of x square plus 2. And if you say this is also decreasing, this is because minus sign is there for in for all x belonging to 1 comma infinity. So for all x belonging to 1 comma infinity, again this value is decreasing. Therefore exactly one real root, okay. Therefore if you look at the entire interval, like every interval, the set of the values for which the equation has exactly one real root is basically the set of all a. That means the a value will be basically a real number itself, okay. That means for all values of real number, that is minus infinity to infinity or positive infinity, these all functions are basically having exactly one solution. Exactly one solution will be possible. All right, so with this the option number a is the right answer. I hope this particular problem was clear. Okay, this particular problem is a very crucial type of problems. Actually, what you need to understand, you can definitely look at this particular problem because in each of the situation, the values of a are basically real number. Now out of this particular real number for which this particular solution for this equation has exactly one real root, you will look for those cases. And if you look at those cases, you will find that for all values of all values of x in the different interval or the cases we considered, we were finding definitely a solution was existing for a. That means that basically implies that exactly one real root condition was satisfied. All right, so that was an important question itself. Okay, so with this let us move to the fourth problem, and the fourth problem is again an interesting problem. Okay, now this is a very interesting problem. You can definitely see this particular problem was actually asked in many times in papers. Again, this particular problem has an idea or the intuition regarding to the complex numbers. So if you look at this, it is saying that the quadratic equation x square plus root 6 plus 3 is equal to 0 has the roots. Okay, so it has roots as alpha and beta. So it has the roots as alpha and beta, and definitely you can apply for the roots. Let me first see. Let me apply the quadratic formula, and you will get it as root 6 plus minus root under 6 minus 4 into 3 divided by 2, and with this you will get the roots as, with this you will get the roots, okay, of the quadratic equation. Sorry, minus over here. Sorry. So minus root 6, okay, minus root 6 plus minus root 6 iota by 2. So that's the basically the roots of this quadratic equation. That is, they are basically alpha and beta. Now again, if I express alpha as minus root 6 plus root 6 iota by 2 as alpha, and beta as minus root 6 iota by 2, like this fashion. And again, if I use the complex notation or the Euler notation for writing these complex numbers, then z is equal to r e to the power I theta. So if you look at both the complex number, the value of the modulus or the value of r is basically is same in both the cases, that is root 6 by 2 whole square plus root 6 by 2 whole square, and that is basically 12 by 4 root, and root under 12 by 4 is basically root 3. Okay, that is basically equal to root 3. That means you can express, that means you can express alpha and beta as root 3 e raised to the power iota. Okay, so e raised to the power iota, and for the angles, if you can see the angles are basically one of the angle. So you can definitely get to the angles as, so you can definitely check out in the first case the angle will basically will be 3 pi by 4, and in the second case, the angle will be, so for this particular case the angle will be, so the minus sign will basically get cancelled and the angle will come out as, so for this particular case the angle will be iota pi by 4. Okay, also you can write this as minus of 3 pi by 4. Okay, so that can also be a possible scenario. Now we have to look for the values of the expression that is basically asking the problem is alpha raised to the power 23 plus beta raised to the power 23 plus alpha raised to the power 12 14 plus beta raised to the power 14 whole divided by alpha raised to the power 15 plus beta raised to the power 15 plus alpha raised to the power 10 plus beta raised to the power 10. So again, a very similar problem to the first problem what we did, to the second problem what we did. Okay, and if you can solve this, if you take this particular alpha raised to the power 23 and beta raised to the power 23 and alpha raised to the power 14 and beta raised to the power 14, and similarly if you club these terms, you'll basically find it this as, again, and putting in the form of the Euler notation, that is z is equal to r e to the power I theta, you will definitely get the values as root 3 raised to the power 23 2 times of cos of, now 23 into 3 pi by 4 is basically 69 pi by 4. Okay, so cos of 69 pi by 4. Okay, and into root 3 whole raised to the power 14 2 times of cos of, okay, cos of 42 pi by 4, and similarly the denominator will be root 3 raised to the power 15 into 2 times of cos of whole to the power 23 itself. Okay, so don't forget this. Okay, cos of, and this will be 15 into, yeah, 45 by 4 whole raised to the power 15. Okay, sorry, very sorry. Why to write 15 again? I'm in converting na. So very sorry. I actually converted. Sorry. Because what I'm actually doing from here, I'm basically writing the r as e raised to the power I theta, and I'm converting this particular e raised to the power r, r into cos theta plus I sin theta. Okay, so I'm converting the exponent into the trigonometric function in the polar notation and the Euler notation. So if I use this, then I won't be getting the exponential, because I can multiply the exponential and write in the format of argument, and into root 3 raised to the power 10 into 2 cos of 10 into like 3 pi by 4, that is 30 pi by 4, and that will be the result. And if you can solve this, okay, so you can definitely solve this. Here the exponent power of root 3 in the denominator is larger, so you can definitely see 23 plus 14 is basically 37 minus 25, and that is basically 37 minus 25 is basically greater than greater. Okay, so from here you can solve it as, so root 3 raised to the power 37 minus 25, that is basically 12. Okay, so that is 3 to the power 6, and if you can evaluate the rest particle functions, that is 69 pi by 4, and 69 pi by 4 can be definitely wrote as, or it can be written 64, that is 16 times, and also we can write it as pi by 4 plus 17 pi. Okay, 17 pi, that is 68 plus pi by 4. All right, so that will be basically pi by 4, and cos of pi by 4 is 1 by root 2. All right, so the required expression what I will be getting is, okay, so that is root 3 ki power. So the required expression, I guess I have calculated the root power is wrong, I believe. Okay, so actually this was plus. Okay, so if I take common, root 3, root 3 power 14, and in this case root 3 power 10, so I will get 4 over here. Okay, and because there is a plus sign, not multiplication. Okay, so that's a mistake also. So because there is a plus over here, similarly there is a plus over here. Okay, so then you can solve it. Okay, then you can definitely solve it easily, as, and this will come out as, so if you take root 15, root 3 to the power 15, then the result will be, this is result is 2 root 2 root 2, because 2 into 1 by root 2 is root 2, plus root 3 to the power, root 3 to the power 6 into, and cos of pi by 2 is basically 0. Okay, because you can definitely write 40, that is 10 pi plus pi by 2, so that is 0. Okay, so that will be 0, and divided by root 3 raised to the power, root 3 raised to the power 7 into again root 2, because this particular value cos of 45 pi by 4 is pi by 4 plus 11 pi, and similarly this particular case is 7 pi plus pi by 2, again 0, again this particular case is root 3 to the power 2 into 0, and this will give you the result as root 3 raised to the power 8 into, and the root 2 terms get cancelled, so this the result will be root 3 ki power 8, and that is 3 ki power 3 ki power 3 ki power 4, and the result will be 3 ki power 4 is basically equal to 81. So with this, the right answer to this particular problem is equal to option number D. I hope this particular problem is clear. Now again, a very similar problem to the very second problem we basically solved for, but these types of problems actually get repeated in different shifts. That's the basically the importance that I wanted to take up, because of which I took up this particular problem. I hope you will definitely recall this kinds of problem whenever it will be asked in your paper. Okay, so with this, let us move to the next problem. All right, the next problem is a problem which basically involves a cubic equation. It is saying that alpha, beta, and gamma are roots of the equation, the cubic equation x cube plus bx plus c is equal to 0, and it is also saying me that beta into gamma is equal to 1, and it is equal to minus of alpha. Now the concept I will be using it as the concept of the correlation between the roots and the coefficient of the x terms in the equation of a polynomial equation. So the sum of the roots, so if I express the sum of the roots, okay, the sum of the roots, if I can say the roots as alpha 1, alpha 2, alpha 3 for any polynomial of n degree of equation, okay, with the coefficient a0, where a0 is not equal to 0, okay, and x to the power 0, it is equal to 0. For this particular this polynomial, we have roots as alpha 1, alpha 2, and simultaneously alpha n, okay, will be the total number of roots. Okay, so these are the roots, and for these roots, the sum of the roots is basically minus of b by a. Okay, and this minus actually comes as minus 1 raised to the power n. Okay, how will you understand what n is? Basically you have to basically go on cyclically repeating the values. Okay, so minus 1 raised to the power n divided by the coefficient of x raised to the power n minus 1 divided by the coefficient of x to the power n. Okay, so these are coefficient. Okay, so I'm writing the coefficient CO notation, okay, for this. So coefficient of x to the power n minus 1 divided by coefficient of x to the power n, and that's how basically get to the sum of the roots. And similarly the sum of the roots with the product taken at 2 at, okay, and similarly the product of the roots. So if I look at this particular problem, the product of roots is equal to alpha into beta into gamma, and that is equal to minus of c. From the equation, from this particular equation, you can see that alpha into beta into gamma is equal to minus of c, and we know that alpha is basically, alpha is given as minus of 1, okay, and beta into gamma, beta into gamma is equal to 1. So from here, if I take the sum product, basically minus 1 into 1 is equal to minus of c. So from here, c is equal to 1. So from here I will get to the value of c as 1. Okay, so from here I get to the value of c as 1, and now Now what I can do is basically, if alpha is equal to minus 1 is a root, so alpha is equal to minus 1 is a root of the that cubic equation, then definitely it will satisfy that particular equation. So if in place of x I put minus 1, so I will get it as minus 1 whole cube plus b into minus 1 plus c is equal to 0. Now what I can do, this is minus 1 plus c is equal to b, because minus of b and taking on the right side, so b is equal to minus 1 plus c, and c is equal to 1. So from here I will get b value is equal to 0. Now I got to the cubic equation as x cube plus 1 is equal to 0. Now this is a very important cubic equation. So if you look at this cubic equation, it can be factorized at x into x plus 1 into x square minus x plus of 1 is equal to 0. So if you look at this roots of this particular cubic equation, so roots of the cubic equation x cube plus 1 is equal to 0, you will find the roots as, okay, so these were roots given as alpha, beta and gamma. Okay, alpha, beta and gamma roots was actually given as alpha, beta and gamma. So you can definitely see this is basically the roots become minus 1, minus omega and minus omega square, where omega is the cube root of unity. So if you have the cube root like this, x cube is equal to 1, you basically have three roots as 1, omega and omega square. Similarly, if you look at this, the roots basically this can factor as x plus 1 into x square minus 1 minus x plus 1 is equal to 0. So for this particular case, that is x square minus x plus 1 is equal to 0, the roots are basically 1 plus minus root under. So you can look at this is 1 minus 4 divided by 2, and this will be actually equal to 1. So this will be plus minus root 3 iota by 2. But if you have minus 1 over here, this is basically equal to omega. But since this is not minus 1 present over here, so you basically minus multiply with the minus, and the result will be minus of omega and minus of omega square. Okay, so this equation has the roots as 1 minus omega and minus omega square. All right, so that's basically the cube roots, that the roots of the cubic equation. Now to basically find for the expression is basically b cube plus 2 times of c cube minus 3 times of a cube minus 6 times of beta cube minus 8 times of gamma cube. I hope I have written it correctly. Okay, sorry, 3 alpha cube. Okay, 3 alpha cube. Now with this the result will be b is equal to minus 0 and c is equal to 1. So this will be 2 minus alpha is basically equal to, alpha is one of the roots and alpha is equal to minus 1. So minus 1 raised to the power 3 minus 6, and beta is basically minus omega. This will be minus omega whole cube, and this gamma is basically minus omega square. So minus omega to the power 6. And we know that cubic root of unity, that means omega minus omega square, basically roots of this equation, that means omega square from here is basically equal to, sorry, omega cube. And we know this result that omega cube is equal to 1. Omega cube is equal to 1. Basically omega basically repeats in a cyclic pattern with a period of 3, and this will give me the result as 2, and the result will be 2 plus 3 minus, and minus omega cube is basically minus also 6, and that is plus 6. Okay, plus 6, and this will be again be equal to minus 8 times omega cube, omega square whole cube. So omega cube is basically 1, and that is minus of 8. Okay, so the result will definitely come out as, oh very sorry, minus will be basically there na. So minus will be there, actually minus will be there. Why minus will be there? Because if it will be basically minus omega whole square whole cube power 3. So the writing part is difficult. Okay, sorry, not difficult, it was basically wrong from my side. This is minus omega whole square whole cube, so the minus 1 ki power cube is there, not minus 1 ki power 6. That's a mistake. Okay, so that's a mistake that you must be looking for in examination. Okay, don't do that casual mistake that my omega square and writing multiplied with 6, you write that minus 6. Okay, and minus omega ki power 6, that will give you a wrong result. Okay, so with this answer will be 5 plus 6, that is 11 plus 8 is basically equal to 19. The result will be equal to 19. So I hope you got to the answer as option B. If you have solved this particular problem, you might have got the answer as problem B. I hope you have done it on yourself. Okay. So with this, let us move to the next problem, and it was a pretty important problem, okay, which involves concepts of cubic root of unity. Alright, the next problem is again an interesting problem which involves the concept of GIF function, that is the greatest integer function. Okay. Alright, so if you look at the equation that is basically given as x plus 3 greatest integer plus x plus 4 greatest integer is less than or equal to 3. Now what I can write is whenever I have a greatest integer function, so any x plus the integer value is equal to greatest integer of x plus that particular integer, where m is basically an integral values or integer. Okay, so if x is an m is an integer, then x plus m whole greatest integer function is equal to greatest integer of x plus m. I hope if you use this particular result, then you will get the equation. The equation will become greatest integer of x plus 3 plus greatest integer of 4x plus 4 less than equal to 7. So from here you will get the greatest integer of x, 2 times of greatest integer of x is less than minus of 4. From here you will get it as greatest integer of x is less than or equal to minus 2. Now it is saying that for all x belonging to real number, this particular equation is satisfied. That means I have to find for the values of x for which this x belonging to real number, this particular equation is satisfied. Now for satisfying this particular equation, let me draw the greatest integer function. So you know the greatest integer function is drawn in this particular fashion, that is at 0, at 1 it is open. Okay, so it goes on like this particular fashion, step functions. Okay, and minus of 1 to 0. Okay, with 0 not included over here, it will be bubble over here and a dark bubble at minus 1. Similarly at minus 2, this dark bubble over here and now open bubble over here, and it is equal to minus 2, is equal to minus 1. Okay, so I have to look for the values of x, okay, for which the results are basically less than minus 2. So less than or equal to minus 2, that means I have to look for all the values of x which are basically like this. Okay, from the minus infinity to minus 1. That means for this particular solution, the solution of x for real number, the x belonging to minus infinity to minus 1, minus infinity to minus 1, but minus 1 is not in, but minus 1 should not be included. Okay, so minus infinity to minus 1 both in open interval, but that will give you the result for x. Okay, and that is basically the set A. So therefore I got to the solution of set A at x belonging to minus infinity comma minus 1. Okay, so that is the solution for set A. So that's the solution for set A. Now I have to look for again set B, and if you look at the set B, what is set B talking about? The set B says that x belonging to real number, I have to look for the values 3 to the power x. Okay, 3 to the power x into summation of, where r is equal to 1 up to infinity, 3 divided by 10 to the power r whole raised to the power x minus 3. Okay, x minus 3 is less than 3 to the power minus 3x. So to look for that particular equation. Okay, now this particular equation, if you look at this is basically kind of a GP with an infinite GP with a ratio which is basically less than 1. That means you can write this as 3 to the power x whole into, and if you put r is equal to 1, it will be 3 by 10 whole raised to the power x minus 1, x minus 3 plus 3 to the power 3 by 100 x to the power x plus this is basically x minus 3 and so on in this fashion. Okay, but I made a mistake, I guess. Okay, because this x minus 3 is not over here. Okay, it is basically outside the bracket. It is basically outside the bracket. So if you look at the x minus 3 is basically outside of the bracket. That is summation. If you firstly compute the summation and then put raised to the power x minus 3, that is the result, which is basically framed in the problem. Okay, so with this you will get it as, so this is a infinite GP whole raised to the power x minus 3 is less than 3 to the power minus 3x. So from here you can solve it as 3 to the power x into, and if you solve this infinite GP, so the sum of our infinite GP is basically first term divided by 1 minus r, where r should be, the modulus of r value should be less than 1, not equal to 1. Okay, less than 1. So this result you will get it as 3 by 10 divided by, and if you see the common ratio is 1 by 10. So 3 by 10 by 1 by 10, 1 minus 1 by 10, that is 3 by 10 by 9 by 10, and the result will be equal to 1 by 3, and 1 by 3 whole raised to the power x minus 3, and if it is less than 3 to the power minus 3x. So from here you'll basically get the solutions. Okay, that is basically x minus, so 3 to the power, if you consider 3 in the numerator part, that is 3 to the power minus x plus 3, so x minus 3 plus of 3. Okay, I hope I'm doing correctly. Okay, so all right. So this will be basically plus 3 and it is less than 3 to the power minus 3x. Now this equation is basically of the format that is 3 to the power 3 is less than 3 to the power minus 3. Now what I can say that if I have an exponential equation like a to the power x, so if I have an exponential equation of the format, let me write it over here. If I have an exponential equation of the format a to the power x, now what I can say that this particular equation, exponential equation, is always positive and it is basically increasing format of increasing format. That means whenever this particular this inequalities implies that this inequality can also be applied for the indices, that is 3 less than minus of 3x, and from here I will get it as x is less than minus 1. So if you can solve this on your own, and you can definitely get this as x is less than minus 1 for this exponential function. So for the set B, I got the set B as x less than x belonging to minus infinity to minus 1, both not included because x belonging to real number. That means from these two equation I am seeing that both the sets are basically equal sets. That basically implies option number C is the right answer to this particular problem. I hope you have been able to solve this particular problem. And this problem doesn't involve the quadratic equations or the concepts of quadratic equation, but what it involves is basically how you are basically able to solve the different equations. Okay, whether it is an modulus function, whether it is a greatest integer function, whether it is a signum function, or different kind. So you must know how to solve those types of problems. All right, with this let us move to the next problem. And the next problem is a very similar problem that we basically tackled in the initial problems as well. So the problem says, now I would like all of you to solve this particular problem on your own, because this problem is again a repeating problem. But this type of problem actually come up in the examination. So I will give you some hint. So you have to look at this particular problem as x square minus 8x plus 15 mod of that minus 2x plus 7. Now again, solving this problem is basically by the case approach. So firstly you get to the critical values. That is, how to get the critical values of the modulus function is basically put the inside part is equal to 0 and you basically get to the critical values. That means you can factorize this as, so if you look at, you can factorize this as x minus 3 and x minus 5 and mod of that minus 2x plus of 7 is equal to 0. Now you basically apply two conditions when x is less than 3, when x is greater than 5, when x belongs to 5 and 3. Okay, between 5 and 3. So for three different cases, you will get three different quadratic equation, and implying the quadratic equation, you will get definitely real roots, which is basically satisfying that particular condition as well. Okay, the particular condition, I mean to say the condition which I basically assume when you consider the cases. On based on the condition, you will get the real roots, and if you sum up all the roots, you will basically get to the answer. All right, so that was the hint from my side. Okay, so this is a hint. I will like you to solve this particular problem on your own. Okay, because these types of problems are actually the problem you will basically encounter in your JEE Mains paper. Okay, these similar kinds of problems are actually asked in many attempts. Okay, in many shifts it was basically asked. Even I remember, like in my JEE Mains paper, I basically encountered these types of similar problems. Okay, so with this I can definitely guarantee you that these types of problems are actually important. All right, so I will be waiting for your comments in the comment section. All right, so let us move to the next problem, and the next problem is basically a problem where we basically have to look for the location of root. So it is a problem on the topic of location of roots. So location of roots. Now again, location of roots is again an interesting part. Okay, so if you look at the quadratic equation, that is 2x square, quadratic equation as 2x square minus 8x plus k is equal to 0. Now it is saying that the number of integral values of k for which one root of the equation, this particular equation, lies in the interval. Okay, it is saying that if this equation has a roots as alpha and beta, so any one of alpha and beta basically need to lie on. So any one of alpha beta, okay, any one of alpha beta basically lies in the interval 1 to 2, 1 to 2. In this particular interval, any one of the root basically lies, and if alpha lies between 1 and 2, then other root lie in the interval 2 to 3. So what I can say from the very, if I try to draw this diagram, okay, that will basically more clear. So if you look at the roots, okay, if you plot the roots on the x-axis and the graph on the y-axis, it is saying me that one root will be between 1 and 2 and the other root between 2 and 3. That means the parabola will be looking like something like this. Okay, that means which basically has one root between 1 and 2 and other root between 2 and 3. So if I write this as alpha and beta, okay, so this will be the basically the case of the quadratic equation. The graph of the quadratic, the expression of the function will be of the similar fashion. All right. So if you look for this, what I can find out that at f for 1 this value is positive, and similarly at f of 3 the value is positive. Okay, so the only way to solve the location of roots problem is not by remembering the different cases, but by understanding the situation, and based on the situation you have to basically look for the different possibilities of the cases that are basically possible. So if you look at the cases, that the cases which I find from this particular problem is that f of 1 is basically positive. What is f? Now f of x I am considering as 2x square minus 8x plus 3. That is the quadratic function that I am that assuming. Okay, so what I see that if I put x is equal to 1, this value will be positive, and similarly if I put x is equal to 3, the value will be again positive. Okay, again for x is equal to 2, the value will be negative. So if you can see the x is equal to 2, the value must be negative. So if you can make the three cases and definitely solve for, you'll basically get to the integral values of k. So let me do so, and if I put that f of 1 is positive, so if I put 1, that is 2, I will get the result 2 minus 8, 2 minus 8 plus k, 2 minus 8 plus k should be greater than 0. From here this result will be k greater than 6. Okay, k is greater than 6. And if I put f of 3 greater than 0, the result I will get is 2 into 3 whole square, that is 2 into 18 minus 24 plus k is greater than 0. So from here the k value will be again be less than. So from here the k value will be less than, so you can definitely check it out. Okay, the k value will be this is actually 8 into 3, so 8 into 3 is minus 24, and 2 into 3 whole square, that is 18. Yeah, so this result will be k should be less than 8. Okay, k should be less than 8. Sorry, k should be not less than. Why I am doing mistakes? Okay, this is again the same thing that you will encountering, that is k should be greater than 6. Okay, so this is the first condition, and this is the second condition, and similarly the third condition, that is f of 2 negative. So from here if you solve this, this is 2 into 4, that is 8 minus 16 plus k less than 0. So that is k will be less than 8. So k is less than 8, and this is the third condition. So from this particular three condition, we will find that the integral value of k will be basically equal to 7, and the value the integral values of k is equal to 7, and the number of integral values of k is basically 1. So with this, the right answer to this particular problem is option number C. That is only one integral solution of k is possible, for which this particular equation 2x square minus 8x plus k has its roots, one root between 1 and 2 and other root between the interval 2 and 3. I hope this particular solution was clear. With this, let us move to the next problem. Alright, so the next question is an interesting problem. So if you look at this problem, it is asking me for the set of S where x belongs to a real number. Now for the values, that is root 3 plus root 2 whole raised to the power x square minus 4 plus root 3 minus root 2 whole raised to the power x square minus 4 is equal to 10. Now an interesting thing that you have to note from here is that if you take root 3 plus of 2, okay, and if you have this particular value, so if you put in the reciprocal of it, where is denominator part, and then you try to rationalize the base, that is root 3 plus root 2, and if you have to rationalize it, to basically multiply with its conjugate, that is root 3 minus root 2, and if you do so, the value will get as root 3 minus root 2 whole divided by, now root 3 whole square minus root 2 whole square is equal to 1. So what I see that these basically are reciprocal numbers. So root 3 plus root 2 and root 3 minus root 2 are reciprocal of each other. So if I assume root 3 plus root 2 whole raised to the power x square minus 4 as a value t, okay, this is a let. Now since this is again a exponential function, that is a raised to the power x, so that means the value of t should be positive or greater than or equal to 0, should be greater than or equal to 0. So if I assume this, take this assumption and write this, then I will get the equation as t plus 1 by t is equal to 10. So from here the quadratic I will be obtaining is t square minus 10, okay, plus of 1 is equal to 0. So that's the quadratic that will obtain from my side. And now if you solve it by putting the quadratic equation, I will get it as 10 plus minus root under 100 minus 4 whole divided by 2. So this result will be 10 plus minus root under 96 by 2. Okay. Now if you look at, I am saying that t value should be positive, should be greater than or equal to 0. So if you take the negative sign, that is 10 minus root 96. Okay. So if you take 10 minus root 96, or maybe you can simplify this as, this will be 5 plus minus, okay, 5 plus minus, and 96 can be written as 24 into 24 into, is basically 24 into 4. Okay, so you can write this as 4 root 6 also. Okay, because 16 into 6 is basically 96, so that you can write it as 4 root 6, and if you cancel out by 2, this is 2 root 6. Okay, so you get to the values as 5 plus minus 2 root 6. Okay, now in this case both the cases are actually possible. So if you look at the first particular case, so if I can take this as case number 1, that is t is equal to 5 plus 2 root 6. So if you can take this case, this is basically the case of root 3 plus root 2 whole square. So if you can see, if you square the both the terms, you will basically get the values of t. That is t is equal to root 3 plus root 2 whole square. Okay, that means root 3 plus root 2 whole raised to the power x square minus 4 is equal to root 3 plus root 2 whole square. That basically implies x square is equal to 6. Okay, and from here you will get the values of x as plus minus root 6. Okay, you get the values of x as plus minus root 6. And for the second case, because both the values of t are possible, because both the values of t are possible, t is equal to 5 plus root 2 root 6 and 5 minus 2 root 6 are possible. Both are positives. Okay, so for the case 2, this is the first case. For the second case, okay, for the second case, t is equal to root 5 minus 2 root 6. So that is basically equal to root 3 minus root 2 whole square. And this will give you the result, that is root 3 plus root 2 whole raised to the power x square minus 4 is equal to root 3 minus root 2 whole square. And if you look at this, root 3 minus root 2, this is basically 1 by root 3 plus root 2 whole square. So this will give you the result, that is root 3 plus root 2 whole raised to the power minus 2. Okay, and if you can solve this, this will x square minus 4 is equal to minus 2. So from x is equal to plus minus root 2. So you will get as x as plus minus root 2. Okay, and this will imply that the possible values of the set n, the cardinal number of the set S is basically equal to 4. That means the values of x are, possible values are equal to 4. That is one set of values of x are plus minus root 6, and the set is plus minus root 2. So with this, the option number B will be the right answer to this particular problem. I hope this types of approach is clear. By letting some number as a variable parameter and then solving the quadratic in it is also an important way to solve problems. With this, let us move to the next problem. Again, this particular approach of letting one variable parameter by some variable term is an important approach. So what you can see from here, it is asking me the equation, this particular equation is equal to 0, then x has what type of solution. So if you look at the equation, that is e raised to the power 4x plus 8 e raised to the power 3x plus 13 e raised to the power 2x minus 8 e raised to the power x plus 1 is equal to 0. Now what I will do from here, if I let e raised to the power x as t, where t should be greater than or equal to 0, because e raised to the power x are always positive. Okay, so from here you can write it as, that is t raised to the power 4 plus 8 t raised to the power 3 plus 13 t square minus 8t plus 1 is equal to 0. Okay, so that's the biquadratic equation. Now what I will do from here, if I divide, so I will write dividing by t square on both the side, I will obtain the equation as t square plus 8t plus 13 is one equation. Okay, one part, and the other part will be obtained as 8 by t plus 1 by t square. Now my goal is to basically get a quadratic in t and 1 by t. Okay, so if you look at this, then t square, and I have 1 plus t square. Okay, what I need is basically 2, the parameter 2. So I can write this as, if I subtract by parameter 2, then I can firstly get the one of this square term as t minus 1 by t whole square plus of 2, because I subtracted, because I took a minus 2, I have to add 2, and if I take this 8 as common, this will be 8 times of t minus 1 by t, and 13 is left out as independent terms. Now if I assume, now if I let t by t minus 1 by t as some parameter p, then this particular will become a quadratic in p, that is 2p square plus 8p plus 15 is equal to 0, and which will lead to the roots of the quadratic in p, and the p values are will be minus 3 and minus 5. So from here you will get the values of p as minus 3 and minus 5, and this will give you the values of t minus 1 by t as one value is minus 3, and t minus 1 by t other value as equal to minus of 5. Okay, now there will be again a quadratic, two quadratic in t. So if you solve this first quadratic, this will be basically t square plus 3t minus 1 is equal to 0, and the second quadratic will be equal to t square plus 5t, this will be minus 1 is equal to 0, minus 1 equal to 0. So from here, if you have to look for the values of t, the t values must be positive values. So if you get the values of t, the first value will be minus 3 plus minus root under 9 minus of minus 4, that is 13 by 2. So from here, the positive value is the only first value, that is if you take the positive sign. So the result will be the possible result, okay, the possible results are this, and the only, the accepted result, so it is better to write as accepted result, okay. Accepted solution are 13 minus 3 by 2, and from here the accepted value will be basically minus 5 plus minus root under 25 minus 4, that is 21 by 2. The accepted result is basically t is equal to root 21 minus 5, minus of minus 4 is basically 29, 25 plus 4, 29. Okay, 29 minus 5 by 2. So that's the possible solution. So from here I get two basically values which are basically the positive values. Okay, now for t, and these are basically the positive values of e to the power x. Okay, e to the power x. So these are the two roots of e to the power x. Now to check for whether the roots are positive or negative, and that is basically checked by whether this particular x, okay, if the value is basically lying between 0 and 1, then the values of x is basically negative, because if you look at the graph of e to the power x, so if you look at the graph of e to the power x, it is basically like this fashion. This is the fun graph of e to the power x. So for x belonging to negative part, the values of e to the power x basically lies between 0 and 1, where 1 is close bracket. Okay, so for being the roots to be negative, the result that is root 13 minus 3 by 2 is obviously less than 1 value, and similarly root 29 minus 5 by 2 is also a result which is less than 1 value, and that basically means both of the roots are negative. Both roots in x are negative. Okay, both roots in x are negative values. Okay, so this will give you the idea that both of the roots are actually negative, and we basically have the roots as, okay, ln of root 13 minus 3 by 2, and other root as ln of root 29 minus 5 by 2, and both of them are negative. So that basically forms the option B, option A, the two solutions are possible and both of them are negative, and both of them are negative. So that basically gives you option number A as the right answer. Okay, I hope this particular problem is clear. This is a very important problem. Many times it is actually getting repeated. 2019, 2018, 2020, 21 paper, this particular types of problem actually get repeated. I hope you have to actually be very careful while you are solving the question for these problems. Okay, careful in the sense in the variable parameter, in which variable you are basically solving for the quadratic. I hope you will be remembering these words. With this, let us move to the next problem. And next problem is again a very important problem, but I would like to all of you to solve this particular problem as a homework problem. Okay, just to solve this particular problem on yourself and come up with the answer in the comment section. But definitely, as like the previous problems, I'll obviously give an hint. Okay, so what basically hint you can apply? You can see the first equation. Okay, the first quadratic, that is x square minus 4x plus 3 whole square root plus x square minus 1 minus 9 whole square root is equal to, you have to solve for this particular equation. Okay, So what is my take is basically, if you take, so from the first equation you can factorize x minus 1 into x minus 4, okay, sorry, x minus 3. You can factorize it at x minus 1 and into x minus 3 under root of them. Okay, so I'm only giving you the hint how to approach this particular problem. And what you can do, if you take 4 common from here, okay, if you take 4 common from here, and you can write 3 as 3 as, okay, you can take 4 common from here and you can write this as, so if you take 4 common from here, that is basically taking, 2 by 4 here, and if you can write this as 12 by 4. So 12 by 4 is basically 3, and 2 by 4 is basically half. So x minus half into x minus 12 by 4. If you multiply by 4, because you can see this, you can cross multiply and do this, and similar fashion, you can definitely take this and write this as x minus 3 into x plus 3. Now why do I need to do this in this particular fashion? Okay, because what you will observe, sorry, not this particular term, okay, you don't need to actually express this particular term, because you will actually get the result, okay, because this particular result will be basically factorized as x minus 3 and x minus 1 square root, and similarly this will be square root of x minus 3 into x plus 3. But for this particular term, if you take 4 common, you'll get x square minus, this will be 7 by 2x minus, and this will be 3 by 2. And now you can factorize this particular parameter, and then you basically get this one of the values x minus 3. And if you have x minus 3 square root, you can cancel on the both the side. And also, what does cancelling implies? This is basically implying that putting that parameter value is equal to 0, that is x minus 3 is equal to 0. Okay, so you will firstly get one solution as x is equal to 3, and the other will be left to you, because you must have solved this type of problem whenever you were preparing for the any material. If you have solved any material, you must have solved this type of problem, right? X, so root under x plus a, root under x plus b is equal to x plus c. Okay, but a, b, c are basically constant terms, so this type of equation you have must have solved. Okay, now this is a different type of approach that you basically apply, because from this approach it must be given in the sense that there will be a common parameter which get cancelled out. In terms of cancellation, this will be taken common, okay, and which will reduce this equation to this particular format, and once you get the reduction to this particular format, you can definitely square both the sides, you can definitely square both sides, and approach, okay, and approach for the values of x, for values of x, okay, then you can definitely approach and get for the values of x. Okay, so that will be basically the idea to solve this particular problem. All right, so I'll be waiting for the answers in the comment section. All right, so with this, let us move to the last problem of the today's discussion, of the today's session. Now this is problem very important problem, because these types of root forming questions are actually asked in not only in quadratic equation chapter, but in upcoming chapters or some important topics of other chapters of mathematics. So if you look at this particular problem, it is saying that, alpha and beta are the roots of, okay, roots of the equation 14x square minus 31x plus 3 lambda is equal to 0. Okay, and similarly alpha and gamma are roots of equation. This is a very important problem. Okay, these types of problems actually get repeated, that's why I am taking this particular problem. Okay, so minus 53x plus 4 lambda is equal to 0. Now many times whenever students go on to solve this particular problem for the very first time, the problem they actually encounter is basically they forget, like after one particular step they don't actually get any hint like in which direction they must apply. Okay, so this is a problem you must remember in like how to solve this particular problem. So this particular problem, whenever you are given with the variable roots alpha beta and you are asked to solve for, you basically need to apply the concept of sum of the roots and the product of the root. So if you, for the first equation, if you apply the concept of sum of the roots, that is alpha plus beta, and that will be equal to 31 by 14. Okay, so that's the first equation. Let me represent first equation. And similarly, if you multiply alpha and beta, the resulting value will be 3 lambda by 14, and that's the second equation. And similarly, from the next quadratic, that 35x square minus 53x plus 4 lambda is equal to 0, the value of alpha plus gamma is equal to 53 by 35. Okay, and similarly alpha into gamma is equal to 4 lambda by 35. Okay, so this is the fourth equation and this is the third equation. Okay, now students get confused after this particular step what they need to apply. Now what my recommendation is to do, so in this particular equation, let us divide the second equation by the second equation. If you divide the second equation by the fourth equation, what benefit you will get? You will get that alpha value gets cancelled, and the resulting value will get beta by gamma is equal to 3 into 35 divided by 4 into 14, because lambda get cancelled and lambda is not equal to 0, so we can definitely cancel it out. And from here beta by gamma value you will find it as the values, you can cancel it out. Okay, so you can definitely cancel by 2 and this will be cancelled by 7. So this is 15 by 8. Okay, so you get the values as 15 by 8. Okay, so from here you can definitely write this beta as 15 by 8 times of gamma. So I can represent beta as 15 times of 8 minus gamma. And now what I will do, then I will subtract the first equation from the third equation. And why I am doing so? Because alpha plus beta minus alpha minus gamma will yield to the result, that is gamma beta minus gamma, because alpha term will get cancelled, and this will be equal to so from the first equation 31 by 14 minus the second equation, it is 53 by 35. Okay, so this is a corresponding result, and if you can simplify, you can take 70 as the denominator common. Okay, and this will be say 35 in 31 into 5, that is 155, and minus, and this will be basically 53 into 2, and that is equal to 106. So from here you can definitely solve it as 7 by 10. Okay, so this result will be actually, the result will be actually from here you can solve it, it will be 49. Okay, it will be 49 by 70, and the result will be 7 by 10. Okay, 49 by 70, and the result will be 7 by 10. Now what I am going to do from here is basically I got beta as 15 by 8 times of gamma. Now I will put this on over here only. So if I put this 15 by 8 times of gamma minus gamma is equal to 7 by 10, so I will get the value of gamma. So from here I will get the value of 7 by 8 gamma is equal to 7 by 10, and this will yield you the result that gamma is equal to 8 by 10. And once I have the value of gamma as 8 by 10 or 4 by 5, okay, once I have the value of gamma as 4 by 5, I can definitely obtain for the value of beta, that is basically 15 by 8 into 4 by 5, and that is basically 3 by 2, and that is basically 3 by 2. So you got to the values of beta and you got to the value of gamma. Now if you have the values of beta, gamma, then definitely you can find for the value of alpha, because alpha into beta, or you can do this first equation, that is alpha plus beta, because you don't know the value of lambda. Okay, so you can definitely do from here that you can do that alpha is equal to 31 by 14 minus beta, and beta is equal to 3 by 2. So this will give you the result 31 by 14 minus 3 by 2 is equal to, so you can solve this. Okay, you can definitely multiply 7 is 21, that is 10 by 14, and that is 10 by 14, that basically 5 by 7. So the alpha value will be equal to 5 by 7. Okay, so if you have alpha is equal to 5 by 7 and beta is 3 by 2, you can definitely obtain for the value of lambda. So lambda from here, if you can obtain the lambda is basically 14 by 3 alpha into beta, and if you solve this, this will basically come out to as 5. You can definitely solve this. Okay, you can definitely solve this is 15 by 14 into 14 by 3, that is 5. Okay, obviously this is 5, and if I have the values of lambda, alpha and beta, then I can definitely say that then it is asking me in the question, it is asking me that you have to find the equation which has the roots 3 alpha by beta and 4 alpha by gamma. Okay, so the corresponding roots, so you can say that the new equation will have the roots. Okay, so the roots are, the first root is 3 alpha by beta, and the value of 3 alpha by beta you can evaluate it as, okay, you can definitely evaluate. So this value will be coming out as, so you can definitely do this alpha, and alpha is 5 by 7 and beta is 3 by 2. So 3 times of 5 by 7 divided by 3 by 2. Okay, so 3 and 3 get cancelled, and the result will be 10 by 7. Okay, and similarly the values of, the other value of 4 alpha by gamma, that is 4 into 5 by 7 by gamma is value is equal to, gamma value was basically equal to 4 by 5. So 4 by 5, again 4 and 4 get cancelled, and this will be equal to 25 by 7. So if we add both the side, and the sum of the roots for the new equation will be equal to 5, That means you have to look for such values where the sum of the root is equal to 5. That means the equation will be of format x square minus 5x, okay, plus, and the product of the roots will be equal to 250 by 7. So 250 by 7 is equal to 0. Now if you cross multiply with 7, the resulting equation will become, so definitely you will observe, this is 49, okay, this is 49, because 7 into 7 is 49, okay. So the resulting equation you will obtain it as, okay, so the resulting equation you will obtain from here will option number option number B, okay. So with this, the right answer to this particular problem will be option number B. You can cross multiply with 49 and you can get to the option number B as the right answer. I hope this particular problem is clear. Alright, now this particular problem is actually important because people actually in the examination format, they get confused, like after a one particular step they don't actually get, like after which this particular moment what next step they need to apply. Okay, so what I do, I basically divided and I eliminated the value of alpha. Once I eliminated alpha, I got to the equation in beta and gamma, and again I eliminated alpha and put the values of beta in terms of gamma to get a one equation in gamma, and from here I got gamma, and once I got gamma I got beta, and if I have beta then I can definitely evaluate for the alpha value. Okay, so that was my take for this particular problem, and this problem is actually important. So I hope you will remember these types of concepts in your examination. And with this, I come to the end of this today's session for quadratic equation. Okay, so that was my take on the important problems of the quadratic equation. Okay, so I hope you have enjoyed watching this particular session, okay, of quadratic equation. Now, what I was actually thinking is that I have already covered the coordinate geometry part. Now, I was thinking to put some practice papers, I mean, as a test in on the topic of quadratic geometry. Okay, sorry, the coordinate geometry. All right. So, on the coordinate geometry, I will be posting one examination, which is basically in the form of an online test. Okay, which will be available in my website. I hope you will appreciate and give the test to access the understanding and also to judge what is the level of preparation for the particular topic of quadratic geometry. Sorry, I mean to say the coordinate geometry as well as quadratic equation. So I will be putting the topics all algebra or coordinate geometry in that, or maybe separate it out. That I will figure it out in the next videos, and also need your suggestion in the comment section. All right. So with this, I come to the end, and thank you.